What's up everybody? I went to the scrapyard today and I found these rather good connectors. These are the connectors for generator assemblies, these portable generators. And I got these exactly the same connectors for my emergency power battery, where the cables running from them. And they fit perfectly in there. I have searched for these connectors for a long time, and at last I found them. A nice solid grip to them. Beautiful. So yes, but that was not the topic of today. Today we are going to have a look on IGBTs and how they work. So yes, most of you are familiar with IGBTs. They look like this in individual components, and they can be like these modules with a half bridge. So there are actually two IGBTs in there and some protecting circuits like diodes and stuff. Like this one, it's a 800 amp 600 volt. Here you can see it. So we're going to try it and see how it behaves. It's a voltage controlled gate on this. So yes, let's connect it up and see how it does. So yes, let's try this module here. I've connected up to one of these IGBTs inside of it with a voltmeter at 22 volt power supply. And you can just turn it on by, oh no, not like that. So if I charge myself up a bit and touch the gate a couple of times, and it turns on like this. And if I ground myself and touch the pin, it slows down. So there's not so much current you need, or actually no current at all. It just runs on voltage. It's an electric field in these transistors that turn them on. And of course you can turn it off by just connecting the emitter and gate together, and it turns off. Very interesting technology this. So yes, let's go and try this big module here. So yes, this is 800 amps. This was just a 75 amp IGBT module. So this one has a very low, has a lot bigger gate field on this one, so I cannot really charge it up like doing that, because it will literally do nothing. So I actually need to physically connect my fingers between those to turn it on. And we've got only 16 volts, but if I touch this one and touch this one, you get the full voltage. Notice this voltage here, 21.9, 21.8. And I will disconnect the motor and connect it here. You can see the supply voltage. If I remove this cable here, you can see it better. So yes, we got 22.3. So it's like a 0.4 volt voltage drop. I want to compare that voltage drop to a MOSFET. So let's try it out and see what we got. This is a IRF 640N. So yes, now it's hooked up. I got a IGBT next to it. So let's turn it on by just touching the gate, and nothing happens. If I touch this one, so I'm actually discharging it by just holding it, and full power. Oh, I just disconnected it. So as you can see, we got this full supply voltage. So there's almost a complete joint together by the drain and the source. So this is almost no voltage drop across that MOSFET. Let's try the same thing with IGBT. So now it's turned off and the IGBT is hooked up. So it's touching those two. It goes up to half of the, or not half, it's a little bit under the supply voltage, and short these two together. You can see it's like 0.4, 0.5, a half a volt less than the MOSFET. So we actually got a little voltage drop across that IGBT. First with IGBT, got a little bit more voltage drop. Yes, and here we got another thing. We got a BGT, or a bipolar transistor. And these are current controlled. So if I hold this and hold this, not so much happens really. The motor turns a little bit slowly. And if I take my fingers away, it will stop completely directly. If I touch harder, it goes up to 19 point something volts, drops a bit. But here I got a resistor, and it almost completely saturated the transistor. And we got the supply voltage here again, 22.3. So I wonder why the IGBT got so much voltage drop across it. I'll maybe try another time, one more time with IGBT. So it's now the IGBT is connected. It got one of these little protective diodes here. And if I touch this, and a little dot on that, and it turns on. But it drops to 21.7 volts, 21.8. Even if I use this little resistor here, it still got that voltage drop. I wonder why that is. So yes, now we have tested the bipolar transistor, IGBT and MOSFET. There's one other type of transistor left, and that's a something between MOSFET and bipolar transistors, which is actually are two bipolar transistors. It's one of these modules. Some of you are very unfamiliar with this, but this is actually called a Darlington. There are actually two BGTs connected in series, so it boosts up the HFE by 2, depends on what the actual transistors are. So let's do a little test on this. So sadly, this is a pretty powerful module, and the HFE is pretty low. So I need actually to disconnect the motor to try this. So yes, the open voltage is like 4 volts, and I'm not doing anything. I've shorted out these ones to the ground, and still for almost 4 volts. But the gate is here. The second gate is here, but we don't need to use it. It just works as a set point, or not set point. It's as a test point. But if I hold this one here and touch this feed wire, we get directly like 21.9 volts. Oh, wrong wire. Here we go. But if I connect the motor, like this, it directly drops down. If I put this little resistor here, yes, and still got a pretty big voltage drop. So that's why maybe you don't need so much current to activate this to pass a higher current through them. But actually Darlington transistors are not so good actually. I much rather prefer IGBT or MOSFET. I don't really want to use a lot of current to turn on a load. So if you don't want to do that, there's always these voltage controlled transistors like IGBT or MOSFETs. That's why they've been so popular, and IGBTs can actually handle a lot of current. But sadly IGBTs got a little voltage drop across the emitter and the collector, so that's a bit sad. But otherwise they are pretty good transistors and have a lot of applications. Yes, hope you found this video interesting. Thanks for watching.